Hi students. In the last lecture, the last video lecture, you have learned two ends of the compiler. In the one end, you have a source code. In the other hand, you have a machine. So you have to consider the two ends of them. So before that, you have seen the phases of the compilation, and then after outwards of the compilation, preprocessor, compiler, and assembler and linker. Okay, so I'd like to focus the two ends. One is the source code. So how to design source code is your main concern, and the other one is the runtime system. So we'll take a look at the runtime system because it is your role to design your own source code. So you can think about design matrix. One coordinate is type. Other coordinate may be your paradigm, language or program paradigm. What kind of program paradigm are you support? Okay. So let's take a look at the runtime system, which is another end. So let me show you the handout today. So today you have to learn what to do. How can I decipher the stack frame? So let me share your my handout. But before that, do you have any questions? Kim Yuhan late. Any questions? No questions. Then I show you what is the problem today. So it is much like very simple, and many of you may be familiar with the stack frame, but I'd like to just from the start, what does it mean a subprogram? So as far as I know, I studied my first program in BASIC in about 35 years ago. At that time, I was making BASIC, and they are providing subroutines. So since making a big program with a single procedure is extremely hard, so you have to divide the contents of the program. So divide a task. That is called a top-down design. So a single procedure, with a single procedure, you have to make a very big program as a whole. So that kind of style is sometimes called monolithic. So it is quite a big creature, and you don't know how to handle them. You have to decipher from the top to bottom. So it is extremely hard. So the early pioneers of programming have made a concept of subprograms. So the concept is easy. So just divide your big program in pieces. So the criteria at the time was that the size of your monitor screen should fit a subprogram. So at that time, the size of the monitor screen is 80 characters wide and 24 lines long. So your single subprogram should not bigger than 24 lines. So it is a crude measure. So they made a concept of subprogram, but at the beginning, in the beginning of a subprogram is called a subroutine. Subroutine means I will use this piece of code repeatedly. So when I call something, it just executes the instructions, a sequence of instructions, which is to achieve a certain task. So at the time, that kind of task is such as printing the banner or printing the menu. So that at that time it was called a subroutine. So it is much like single code, such as def print menu in Python. So it's not accepting anything, just printing a sequence of statements. So executing a sequence of statements. However, from after a little while later, they need a data transfer. They need some data. So sometimes you need to pass some data here to a subroutine. So the subroutines evolved into another concept which is called the subprograms. So subprograms is conceived after a while. The subprogram is accepting some data, and it may produce a result. So the subprogram is much a fancy concept that it is accepting input from outside of a subprogram, and it may produce the output. And the input is arguments, and the output is just a return value. So the parameters of a subprogram are the input, and the return value of it is the output generally. And the subprogram can be classified into two categories. One is a procedure, the other is functions. So a function can return a value, the procedure is not. It cannot return a value. Since a procedure cannot return a value, what is the value of a procedure? There's no value, and the procedure should change the status of the current program, current environment. So it is called a side effect. Changing the outside is called a side effect. But ideally, a function should not take side effects, but just return a value. So the subprogram can be divided into two parts. One is a procedure, the other is a function, and procedure is for taking the effect, which is called a side effect. But function is for producing a return value. So that is just an outline of subprograms. So any questions up to here? No questions? Okay. So I'll just take a look a bit later. Stack frame. So the second so how to implement a subprogram is the main task of every compiler writer. Since the subprogram should maintain its data because it accepts some input from the outside. So it should preserve that kind of data. It should maintain that kind of data. So a stack is used for storing the data for subprogram. This is really a big jump for implementing a subprogram. Before that, they didn't make any stack frame, such as Fortran, early Fortran, early BASIC. They don't have the facility of stack. But the stack concept is contrived from the early compiler writers. So calling a function G from another function f, so f calls G, if f calls G, and G is called callee, and f is called caller. So the callee stack from, let's think about that. This is a stack, and stack grows to this direction. So if this is a frame for saving the data of f, then new frame for G should be built on top of f. Okay, why? Because G is returned before f. Therefore, stack is very adequate data structure. Since the order of call and return it just has the similar structure of LIFO structure, which stands for last in and first out. Okay, so this stack is very essential structure for implementing subprograms. So the stack for subprogram is called the control stack. So this is called the control stack. This is called the control stack. The control stack consists of several frames. There can be several frames here, several frames. And each frame is saving the saving the data of active subprograms. Active subprograms are those which started but not terminated yet. So I'm active because I'm currently here but not terminated yet. So I'm still live, so I'm active. So that is called active subprogram. So the stack frame containing all the local variables, including the parameters, plus additional bookkeeping data to maintain the stack frames of active subprograms. So most of the CPU provides two special registers. Do you remember the CPU structure? CPU. Inside of the CPU, there is some ALU, which is a computational unit, and CU, which is a control unit. And there are lots of registers here. And one of the register is an instruction pointer, or sometimes it is called the PC, program counter. So it stores the what execution to what instruction to be executed next. And some of the registers is that base pointer and stack pointer. Base pointer and stack pointer is just for maintaining the current stack frame. So if the stack grows in this direction, the baseline of the stack frame is maintained by base pointer. And top of the stack frame is maintained by SP, stack pointer. So you have two pointers. One is the pointing the bottom of the stack frame, and the other is pointing to the top of the stack frame. So my question is like this. If your stack frame is just like a fixed size, so why should we save both of the pointers? Any idea? Base pointer, and you have a stack pointer. But you know that you can estimate the size of the stack frame because it has a finite number of local variables, finite number of parameters, and finite number of bookkeeping data. So it can be pre-computed. So why do you need stack frame? Because it can be always computed from the base pointer. Actually, the size of the stack frame is not fixed. Okay, so the list size is fixed. Minimum size is fixed. But it is not actually, because you need some temporary storage for evaluating your expression. In that case, stack is grows for encompassing the temporary data. Because your temporary data is usually stored in your register, but as you know, you have only limited number of registers. So typically, at the ancient time of 8-bit computer like Apple I, can you believe that in your Apple I, it has only single general purpose register? So at that time, it was called accumulator. But typically in nowadays you have about 8 or 16 registers. But some of them is special purpose. So the general purpose registers, you have a very limited number of general purpose registers. So you need additional store. So where can I store them? On top of your control stack. So that's why we have to maintain two pointers. So the base pointer is also known as a P, frame pointer. Sometimes it is called the frame pointer to the bottom of the stack frame, and the stack pointer points to the top of the stack frame. In most computers, the control stack grows from the highest address to the low address space. So actually it is not grows in this direction. This is high. And this is low. So your base pointer is generally greater than, the contents of the base pointer is generally greater than stack pointer. Okay, so if you take the notation in C, if it's referencing, no, not referencing, just the contents of it is just bigger than the stack pointer. So therefore, base pointer is usually points to the higher address than stack pointer. Got it? Okay, good. So let's take a look of today's problem. So you want to dissect a stack frame. You want to analyze a stack frame according to, based on the code. You know that how to get the code from your source code in the last lecture. You have seen in GCC, you have a special option. GCC has a special option -S to generate an assembly code. So to make a stack frame explicit, I just devise a function which is just returning 8 times 2. So at that time, 8 times 2 was here in your last program, but I just made a function here to take a look of the stack frame. So let me show you the execution result of this program. The title of this program is named as twice. So this is such a small treatment for you because it is a very famous idol group in Korea. So it is just that. So I just resharing this code. So you can type the twice the C. So this is your original code, and you know that type twice fun.c. This is a modified code. So once you install make, so you can install make like this, pacman -s make. Then it will install make on your platform. So after installing make, you can make what was that? Twice fun without .c. Then it will compile twice fun.c, and it will generate twice fun. So let's execute twice fun.exe. So it is waiting for your input. So when you type 1, it will print 2. So when you type 5, it will print 10. Okay. So I'd like to make gcc -s twice fun.c. So it will generate, as you know, the twice fun.s is just created. So you can check this from here. So how about this one? So you know that twice fun.exe is just created. Sorry. How about this one? And you can see that twice fun.s is also just created. Okay. So let's take a look of the contents of twice s. Okay, so let's take a look. vi twice fun.s. Then you know that there is a certain label twice here. Twice, you have a label twice, and you have another label main. So this part is around this part is twice function, and around that part is a main function. So your main function has a call instruction to twice. So your twice function will be called from here. But let's take a look of the initial part of the main function and twice function. So the beginning part of the function is very similar. Push Q and move Q up to here. Okay. So it seems that it is it is storing some data to your stack. And the similar code is here. Push Q, move Q, okay? So similar structure is, you can find the similar structure here. So as I said before, BP is a base pointer register and SP is a stack pointer register. So the meaning of this, you are pushing the current base pointer onto the stack and you are copying the current stack pointer as a base pointer. So you are switching the role. Current stack pointer becoming the base pointer, and you may push something others, so your stack pointer is maintained as before. Okay. And other code is just for executing the body of the function. And in the case of main, it has a similar thing, and other code is just for implementing the body of main. Okay. So the role of what is the role of these two instructions? The role of these two instructions is just setting up your runtime system, control stack. Okay, so let's take a look. Let's go back to your handout. So compiling this program into an assembly code, you can find out the beginning part of the function starts as follows. Push Q base pointer, move Q stack pointer to base pointer. So as you know, this follows the AT&T style. So you know that this is generated from GNU. So the GNU assembler, which is sometimes called GAS, GNU assembler, they are taking the style of AT&T style. You know that Unix is built from the AT&T, okay, which is a telecommunication company, where your early pioneer, whose name is Dennis Rich, and Brian Kunigan, is making the original C. So the GNU is following the tradition of AT&T. There's another style, but it's just reversing the direction. The AT&T style, you are using this kind of direction. So move Q means that your stack pointer is moved to the base pointer. So you are setting a new base pointer. So this sequence of code, this sequence of instructions at the beginning of the function is called the prologue of the procedure. Prologue of function saves the current base pointer and sets it to make a new frame. So decipher the layout of the stack frame and modify the assembly code to add an additional function, such as triple, which will return the triple of the arguments. This value should be printed as well. In short, a modified assembly program should behave like the following code. Okay, return. So this is twice. Sorry, this should be modified. Sorry, this should be modified as triple. It is wrong. Triple. So you'd like to call twice first, and then you'd like to call triple later. So, but you don't have to modify the C code, but just modify your assembly code, because you have to understand the structure of your assembly code. So let's take a look. How can you do that in assembly code? So as I said before, this is your assembly code. So you may write this. What is a good name? Quad.s. So I'd like to edit quad.s. Okay, so you know that this is a quad.s, and you want to deciphering where it is starting. It is started from twice, or text twice. So you can set number. Okay, so starting from 2, you'd like to copy it to here up to 17. So you can starting from 2 up to 17 and copy it. Okay, it is yanked. And then you can just type P and it is created here. So twice is in double. So twice in double. So you can make a quad. Make a new procedure quad. So instead of twice, quad. You'd like to new procedure quad. Quad. Okay. So your new quad function is created, and instead of calling, so you have to implement the additional code, but that is your task. I'm just exemplifying where is the location here. You have seen that you are calling twice. Instead of calling twice, you'd like to calling quad. And you know that calling quad can be implemented very simply. Just add the EAX and EAX again. Okay, so let me save this as quad.s, and you can just GCC quad.s, and it will generate the a.exe. Can you see that a.exe just created is 17 now, so 5 p.m. now. So let's execute a.exe here. So when you type 1, 4 is printed. When you type 5, 20 is printed. Okay. So you just modified your code. Okay, you just modified your current code. So this is how can you handle them. So let's just resharing the original one. So you can test the result by GCC for the assembly code, and based on this experiment, make a report for the reference assignment 3. You can write a report in Korean, but you can your report should contain the following materials: the layout of typical stack frame with some explanations, and decipher the assembly code for the function twice. Okay, so the function twice should be deciphered line by line, and the modified assembly code including the function triple. So in my case, I just included quad, but please add a function triple with some explanations. So the following shows 2 sample input and output for the modified code. So your code should still execute twice function and then execute triple function. Your function should execute twice function and then triple function. Got it? Is it possible to do what? Call twice and triple? Yes. In assembly, yeah. So you should modify your main function too. I mean, you mean the twice comma triple. It is not. It is very fascinating to do that, but it is not, because you have to call a function by one, and you have to set up the arguments. before the call. So if you any further question, then you can email your TA, but it may take a very somewhat long turnaround time for the reply. But if you don't have any further question, let's call this a day, okay? And see you next time. Bye-bye. 수고하셨습니다.